guys, welcome back to another video. First of all, I want to clear things up by apologizing for not having posted in around 9 months, almost a year. Most of the content for this video I did film in December, but haven't really had the time to edit and post the actual video. So I'm finally posting, and I want to apologize just for such a long delay. So yeah, but without further ado, let's start the video. So to start off, let's do a quick recap about each of the videos I've posted so far on my channel, just to understand where we are at this very moment. So the first video I posted was the video Forces on a Rocket. Whether you've watched it or not, it's pretty self-explanatory based on the title. It explains the forces on the act on a rocket and how they affect the rocket. The three big ones being force of gravity, force of air resistance, and force of thrust. And then the next video I posted was what is the height of my rocket, where we use trigonometry, we use physics and simple algebra to calculate the approximate altitude that our rocket reaches. My third video was my most popular video so far. It was titled Making the Easiest Rocket Fuel Ever. Don't get me wrong, this fuel was very easy to make, but was pretty difficult to really take care of after I had made it. As you might recall, if you have watched the video, I left my motor just sit in a humid environment, which ended up putting moisture in the fuel. So once we put it on the test stand and we ignited it, it just didn't catch on fire. But again, we learn from our mistakes. So now we learned from that we keep our motor in a dry and cool environment to ensure that our motor ignites well and, combusts in the way we want it to. And that brings us to our fourth and most recent video, where I compared an Estes engine against my engine. And that was probably the biggest fail I've ever had, because my engine just had a bunch of things go wrong with it. And we'll sort of talk about that during the video. I've been sort of yapping around, so I'm just going to sort of get on with it. But yeah, without further ado, let's get on with this video. So before I get to the really main point of this video, where we actually test our fuel again in a new molded casing, I just want to sort of go over the molded casings I have, the casings I have used, and the one I'm going to use in this video, just to sort of compare and contrast the pros and cons, what they were good with, what they were bad with, and just go from there. So we're going to go with a quick time warp and little montage of me riding on the board, just for me to erase it in 2 minutes. But anyways. And we're back. So, first of all, we're going to go over the metal pipe, which you may or may not remember from one of my previous videos. It really wasn't that expensive. It was around probably $7 or $8 for everything, including the washers, the pipe, and then the condenser thingamabobbins. I forgot what it was called, to be honest. So yeah, that was one of the pros. It was relatively cheap, but it was severely outweighed by the con that it was extremely heavy. Yeah, that pipe was way too heavy. So that was really just a no-go. And then, as well as we had to weld the nozzle on. If you recall from the video, it's sort of the washer, which acted as the nozzle, sort of just flew apart after a few seconds of ignition. So we sort of need to weld it. But I have been looking into it and possibly I kind of want to experiment and see if we can solder it and put layers and layers of soldering on top of it and see if it can still sustain that. Because if it does, it'll produce quite a bit of power through that that nozzle. So yeah, that's really it for the metal pipe. And then we got the cardboard. As you can probably guess, cardboard, extremely cheap, really, really cheap. I literally just found it in my recycling bin. So that was really good. Really light, extremely light. But as you probably know, it's kind of flammable. It's kind of burns. So when I did test it in my last video, there was quite a few holes that ended up coming through the cardboard, and just, you don't want that in a motor casing. So yeah, not a good thing to use, unless something I'm also keen and interested in trying is putting like an ablative coating inside the cardboard, which will act like as a heat shield inside the cardboard, which might work. So something I'm interested in trying. I don't know if I will though. Sort of, we'll see what goes on. And then we have the nozzle. The nozzle fell apart last video when I tested with the cardboard. It just went away. Just didn't work. And that leaves us to the plastic one that we're using today. This thing was bucks expensive. The actual nozzle cost like $9.99, but then the shipping was like $15 to $20. And my brain was like, my brain decided to just only buy one. So that was probably a dumb decision by me. I probably should have just bought a few and then saved on the shipping costs and stuff. But anyways, other good thing about, so that was sort of the con, but the other good thing is like it's heat resistant. Like it's made for rockets, so it's not gonna let anything go through that shit. Like, yeah, it's gonna stay together. And then it really looks perfect because it's a motor. It's a rocket motor casing, so that's what it's supposed to do. So it looks like a rocket motor, and I have good hopes for it. Anyways, I will quit yapping. I'll send you guys over to the shop where I will be building the fuel. Enjoy. Starting off with ingredient number 1, we want this to be about 35% of our fuel. Here's our nozzle. Time to fill it up. Now we mix. Ingredient number 1, the good stuff, the non-flammable stuff, all good by itself. I'm gonna put it in here and then I'm gonna put the lid on. And then I'm gonna mix it up to make sure it's very consistent. Here we go. You're back. I'm back. So I may or may not have used ChatGPT to find the best ratio of the good stuff in the good stuff and the bad stuff in the good stuff. So yeah, ChatGPT also, I found the density of the fuel, or what it's supposed to be, the density it's supposed to be, and then found out the weight I'm supposed to have to fill up this motor to a reasonable amount. So if it's completely wrong, not my fault. Speaking of which, now I want to add more just in case. You know what's actually really annoying, guys? The bad stuff of the good stuff, I cannot find it at any store now because it's a retired product. So, I either buy it extremely overpriced or I just buy the straight up chemical that it already is. But I've never tried it with a straight up chemical it already is, so I'm kind of scared to do it. Let me know down in the comments if I should or should not do it and risk blowing myself up. Cover this bad boy up. Now we shake for 2 minutes. Give me a 2-minute montage. Add some salsa music. Now that I'm actually going to be touching the fuel with my hands, I need something very specific. Do you remember what it is? Is it A, a rope, B, a brain, C, a pair of slippers, or D, gloves? If you said A, you are correct in being wrong. It was actually gloves. I'm gonna go get them. As you can see, I am not a doctor. Although I did think about being one. Speed. don't chase your dreams because they make a lot. Don't make things your dream because they make you a lot of money. Make your dreams what you really want to do in life. Your job should be, your dream job should be something you do for free. Building rockets, I would do for free all the time. But I don't. Please sponsor me. Look at that good stuff. It isn't crack. It's rocket fuel, baby. Dang, I'm spilling some. So yeah, the assembly went perfect pretty much until my camera decided that it was done with its life. So I ended up just finishing up packing the fuel without even knowing that it was now recording, and stored it in a cool and dry environment because that's what we learned from the past videos that I've made, and waited for nightfall to test our rocket. And well, here are the clips. 3, 2, 1. The test was going perfectly until it decided to just explode on me. So, yeah, I'm going to change this really quick. It explodes. Yep. But the real question is, why did it explode? And so my immediate thought, of course, was just, well, the pressure inside the motor was just too big for the casing to hold it in. But more specifically, what was causing that pressure buildup inside the motor? And so I narrowed it down to most likely that the throat and nozzle diameter are just too small, so the fuel can't leave the engine fast enough as it's burning, so it causes the pressure to just rise, and the casing can't hold it in. So, boom. Or the motor casing walls are just too thin, but that's not something really we can change because I can't really make my own molded casings because I don't have the equipment. But anyways, so yeah, something we can't really change. But we can change the first problem, the first reason why this problem occurred. The other reason why this problem could have occurred is because the casing wall is too thin to hold in that pressure, which, I mean, is like, it can be a reason. If it was thicker, yeah. But again, I don't have really control over that. So I kind of can't do anything about that. So what we are going to try to do in the future, what I'm going to try to do in the future is two things. Try to increase the nozzle diameter and the throat diameter so that the fuel can leave the motor more quickly, so that either the pressure increases slower or it just doesn't go as high enough that it explodes again. So that's one of the things I'm going to do. And then I'm also going to try to change the grain size of one of the ingredients I use. Right now it's powdered, which sort of speeds up the burn process a lot more because this ingredient is like what makes it so, it's like the propellant. It's the thing that catches on fire. So we're going to try to increase the grain size to slow down that process and hopefully slow the build of pressure. and not cause it to explode. So yeah, that's what I'm gonna try to do in my next video. Sort of mix around, see some different things, and see what we can get to, and hopefully we can get a fully successful motor test with no explosions, no false ignitions, or no random nozzles popping off. And yeah, we'll see you next video. And thank you very much for watching this video, for all of you that made it this far. And if you like this content, if you like this video, please consider liking. If you like this content and you think you'd enjoy this content, please consider subscribing to this channel. And thank you guys so much for the support.